This video on the Tascam 122mk3 full rebuild. It's a video series, and this goes back to the very beginning of receiving the deck and opening it up for the first time and having a look around. I've broken out different parts like the capstan motor rebuild, the real motor rebuild, and a few things like that, and I've put them into separate videos. And I will link to those videos in the description and cards as the sections come up. So the first thing I want to do is see if I've got motor function. I zoom in here on the capstan motor. I know it's dark there, so let me just put a red mark there. And I've activated the leaf switch and the motor kicks on, so that's a good sign. I have no idea if it's fast, slow, erratic, but it turns on, so that's a good sign. Just push the leaf switch, see what other kind of functionality I have. Okay, that works, but boy is that noisy. Let me grab the mic here and so you can hear it with me. Okay, so that's what the rewind and fast forward sounds like. And that's what the play sounds like. That's okay, we'll take care of all this. Let's see. Let's just do this again quickly. You can also see how the head stack is just struggling to come into place. That shouldn't be that way. That should be very, very crisp. So that's fine. Gonna have to do a little cosmetic work on it. And this has obviously been into before. Looks like I've got a cut off piece of wire tie right there. And of course the wires are sort of debundled or on their way to being debundled. And what do we have back here? Looks like a little piece of Teflon insulation that's been stuck there probably for many years. I'm assuming that this machine came out of the same studio environment that the last one this client sent me. And so it doesn't surprise me that it has been maintained and into before. I'm sure it's had heavy use and has been, maintained well. So connectors are really kind of tight. I want to be really careful with these. I don't pull on wires. I try to grab the connector with the pliers and just rock it out. Get the first clear look at the heads here, and they look good. I don't see any grooving or anything like that, so that would be a good thing. On the other hand, this does not look so good. These windings have been dealt with or attempted to be dealt with, and I can see problems in the future on that. The motors on these are always a little bit loose, and you'll see when I reassemble them, I put a little drop of blue Loctite on the shaft threads, so that won't happen again. I've never seen one of these that the motor wasn't loose like this. Alright, so I think let's just get it apart. I'm still kind of thinking whether I should try to recap this now and evaluate it and then finish removing it and rebuilding it. What I really wanted to do is get a good look at those windings and what I might have going on here. And this was very clearly an attempted repair and a splice on that lead, which I'll need to take care of. It's also uninsulated. Here's some very, almost looks like burnt grease. It's usually not black and thick like that on the capstan thrust bearing. And I'll put a card here for a detailed video just dedicated to the rebuilding of this capstan motor. And I'll also have a link in the description and at the end of the video. This is going to be a good demonstration of the C gear right there, because this one's actually intact, and generally when these are opened up they're broken in many pieces, but this one's still there. So this will be kind of fun to show what happens to them. Pop that little clip off. Yeah, that one just slides off. Now this infamous C gear up above that is the one that always breaks. Now this isn't really a defect so much as it is a maintenance item. Involute gear trains like this one are noisy. So the custom is to place gear of different and generally softer material somewhere in that train strategically to quiet the whole assembly down. And in this one, a plastic was chosen that was softer and maybe affected by the grease. I'm not sure about that. Very likely was. And also just, cured and cracked over time. So I don't really consider this a flaw. I consider it maintenance, normal maintenance. And that's true of, even car engines, same way. So not a flaw, but a feature. But this one is, the grease is turned into glue, and you can see just how stuck it is on that shaft. But it's still together, which is amazing. Or it was together. And that's great to be able to show this. Now I'll take that out and show you just how brittle that gear really is. These tweezers, I don't think they can put a pound of torque on anything. They're just very thin. And if they can break this gear, then it doesn't take much. Let's try it. Now the replacements are much higher quality than these. There are several different styles and types of plastic. Not the 3D printed ones. I would avoid those at all costs. There are some injection molded ones. They're good quality. They're harder plastic, probably similar to the other gears. They're probably a little noisier than this. But the ones I use are from a German seller. He's on eBay, and he laser sinters his gears. They're obviously the most expensive ones, but it's a good process. It's a very precise process. And the plastic, the thermoplastic that he uses, should make this at least as quiet as this material that Tascam used originally. And it will outlast the factory gear by a fair bit, or should. Couple of screws, couple of springs to get the door off. There's the nut to get the motor assembly out. And this, of course, is typical of the idler tire. That's generally how they are. Then we'll just get this motor out and check on it. I'm going to put another card right here, and also a link in the description to the full and detailed motor rebuild on this real motor. So check that out. So now at this point I've already rebuilt the motor. This is that little felt friction pad on the back of the gear. And it looks to be in pretty good shape. The gear looks good. So what I'll do is lubricate these up and scuff up that felt pad. These are replaceable if need be. Most of the time they just need a cleaning, blow them off a little bit, and I just rough them up a little bit with a brass brush, and that generally gets them right back to the like new condition. And that's it. This one's clean and dry, doesn't have any oil contamination or lubricant contamination. Not visible anyway. Just want to make sure the bore's clean. This is just a little IPA. Same thing with the idler tire. Sometimes these will be contaminated from the residual oil from the tires, so I always clean these up really well. I have brand new fresh stock of these idler tires, and I've just received these. The ones that I was buying in the past I wasn't happy with, and I never did even use them. I ended up buying tires from eBay because I wasn't happy with my vendor's supply, and I've just recently found these, and I got a good supply of them, and I'll be offering these I guess on eBay, Reverb. And these are the best tires I've ever found for these. They're just very high quality, very precise. These are my previous inventory, which I never did use. I didn't like them. You can see that they're, even though they sell them as being a particular size, they're not. They also have casting ridge down the middle, very pronounced, right there. And so those never got put in any of my builds. They're just scrap. These are nice tires, and like I say, as soon as I have a chance, I'll get these listed and put a link in the description for those two. It's a good quality rubber. It's got a nice grippy feel to it. I'm really pleased with these. This is the gear that is press fit on the reel motor, and press fit in plastic is an interesting thing. In metal, we have standards for interference fits depending on how much of an interference fit you want. With bearings, there are standards that we go by on those to do the interference fit. Plastic is a different material. There's a lot of information that's required, including the formulation and a lot of other things that's required to get a correct press fit with a plastic part onto a steel shaft. And obviously I have none of that information available to me. There are calculators online, but you need the data first, and that's not available. So what I do know is that plastic shrinks over time because it continues to cure throughout its whole lifetime. And that's probably the reason this was so difficult to get off. If you watch that other video, you could see that it was not easy to remove. So that one's linked again here. I'm just using a fiber brush here to clean out in between the teeth. There was a little bit of built up, who knows, contamination in there, debris. Obviously, I want these to run as smoothly as possible. Clean up that bracket. I probably mentioned this before, I'm using Kim wipes here or anything that doesn't shed fibers. I want to use a small amount of the correct lubricant reassembling these, but I also want to be very deliberate about where I place the lubricant. You can see maybe on the bottom of that shaft there are a series of concentric circles, and that is what creates friction on the felt pad. And so I don't want to get any grease or any contamination down on that pad. And if I lubricate the shaft, instead of putting the lubricant down here in the middle of the bore, it will push it down onto that felt washer. So just the bore on this. And not very much at that. Of course, now this is a sliding knuckle, and so I want to get lubricant on that, and I want to get lubricant on the thrust side of these pulleys. Make sure the tire's absolutely clean. There it is. What I want to do here is determine what the bore size of this is, knowing that the gear is most likely to split on that hub, not on the larger diameter portion of the gear itself, but the hub is where it's typically going to split. So all I'm doing is I'm just determining what the bore size is, and then I just want to relieve that hub just a little bit. Now I know the gear is a little bit smaller than what the spec on it would have been at the factory, but they also have other properties that happen, which it's interesting the way plastics interact with metals like this. But all I want to do is I want to relieve the hub side of that with a small reamer that is, it's a guess in the size, but it's a pretty educated guess. And I'm taking just the tiniest amount of material. You see, I'm only going as deep as the hub. I'm not going onto the gear section at all, so I shouldn't be changing the friction that's driving that. And that's it, just a little tiny bit. Again, make sure it's absolutely clean. Obviously the motor's been rebuilt at this point and is operating correctly. I'll just use this dowel pin as a guide. And at this point I can just press it back onto the shaft easily by hand. After I replace this thrust spring. Needs a little bit of end play there. Just need to put the shield back on. I have since acquired a small stock of this motor. I found that they were available online, and so I had to order them from, I can't remember, overseas somewhere, but I did manage to get a few of them, and so I'll have those as a backup. I'm just basically copying what was done before. I'm using adhesives that are available to me. This is 1357. It won't harden up and split. It will stay slightly pliable. It's similar to what they used. Again, just clean the solder joint, start out with fresh material. tin them with fresh solder. I'll move on to servicing the reels. Little tiny spring retainers in here that'll love to get lost. Tiny little Delrin washer in there. Again, I'm going to lubricate all of this. I've shown most of this in other videos, and so I'm fast forwarding through and trying to keep it as not boring as possible. But this is the procedure. And I go through this exact process on every deck I rebuild. I do like to put a little lubricant on these reel shafts and bores. I think it's very important, even though a lot of times I think the factory will run them dry. Okay, and it's pretty obvious how all that goes back together. Get the leads back on the reel motor. And I like to strip these, clip them off, get a fresh start on them. Tascam chose some very narrow gauge wire on these, and on certain parts like this, I think it's just good to get a fresh lead on it. Again, just a little bit of flux. And then just tin the ends, try to keep the solder and the flux away from the insulation. Clean it so it doesn't get under the insulation. And then just hook them. And that little bit of free wire before the insulation just helps them be a little bit more pliable, so they're not so liable to break off. I'll clean these contact surfaces on the cam PCB with alcohol first, starting out with IPA, then some contact cleaner. Get rid of the oxidation. I use that good old Zep stuff. And then some new dielectric. And I'll just put a little paper on there to cover it up while I'm doing the rest of the deck. Also want to get a little bit of oil on the front bearing. on that control motor. Unlike the real motor, this one feels really good. Or unlike the real motor felt, it feels great now. Now the owner sent all new gears for this. However, I still prefer the factory ones if they check out okay. So I'm going to clean these up, and I'll inspect them all with a backlight, a strong backlight, like a flashlight or something like that. Make sure there's no visible cracks anywhere. I still prefer to use the factory gear if it's in good shape. I've had good success with doing that. Same procedure. I've removed the oxidation on these, and I want to keep it off, and so I'll just put the dielectric on, and then just keep it clean with a piece of paper. I should say butcher paper. This is the paper that doesn't, this isn't writing paper. It's a butcher paper, so it doesn't absorb all the grease. This is just some of the ultrasonic cleaning solution I soak the other parts in. It's non-corrosive, and as long as it's used with distilled water, I can actually put steel parts in this and it won't corrode them. But it's also just a good cleaner. Yeah, let that soak for a little while. I don't generally put plastic parts in the ultrasonic. I think it's okay, but I don't usually do it. Just finish up with a little isopropyl. And we'll finish the disassembly here, and then throw the entire thing in the ultrasonic. I'll back these off a little bit at a time and reduce the pressure on those very fine threads. Head looks really good from this distance. We'll put this under the microscope and see how it really is. Yeah, I've got some fresh solution mixed up here. And we'll just put these parts right in the ultrasonic. Maybe give them a wipe first. Don't need all that grease in the solution. You got plenty of grease on this one. Yeah, that's a lot. Okay, all of that will go straight into the ultrasonic cleaner. And while they're in there, we'll clean these leaf switches. These are extremely delicate. These little plastic covers can break so easily. And it just have to go very slow. Contact paper, contact cleaner, and a piece of paper. They look good. And not a bit of anything really seemed to come off, so that's good. So before I put this under the microscope, I just want to give it a quick polish so that I can really see what's going on. Okay, parts are clean. Sorry about the focus. Okay, let's go have a look at these heads. I just gave them a very quick polish. They looked good to me under the loupe. I didn't see anything that concerned me. Of course, I've never played this deck, and so I don't know. I haven't tested it. But physically, they look good. And I do have replacement heads here. But these are looking pretty good. I'm still working on my microscope lighting, so these views will improve as I have more time to work on this. Might be just a little bit of surface corrosion from, lack of use. But that will certainly polish off, no problem. Let's get a little bit closer. And those very minor scratches there are most likely just my coarse polishing compound, because they're certainly not going with the direction of the tape. So I feel pretty confident at this point that these will be okay. No breakdown on the gaps that I can see at all. I could play around with this kind of stuff all day long. Wonder if I can have any light to get a little bit closer. Yep. Yeah, I can work on that a little bit. I think I can improve that lighting. Well, the point is I'm satisfied that there's no gap breakdown, and the rest of the polishing I can do just fine. So let me just quickly go one more step up. Yeah, I think I gotta do a little bit more work with the lighting to get to this magnification. Okay, let's move. Okay, I've got them taped off, and I just want to do a little polishing on those guides. And I'm putting a red Sharpie marker, and I'll just be taking off that Sharpie marker with a 3000 grit. And that is, I don't know the micron number on this, but it's a US 3000, so that's going to be maybe a little finer than that on the P grade. I just want to smooth those, basically break the edges, break the corners, smooth them out. The tape, the guide should not be guiding the tape. They're not railroad tracks. They are guardrails. But when the tape engages and disengages and goes through the tape, that little bit of roughness on the guides, it can hurt the edge of the tape a little bit as it's entering and exiting. And these are just stamped steel guides, probably stainless, I suppose. So just a little bit of glide coat, corrosion inhibitor, and polish that off, and that's how they turned out. Kind of degauge the whole transport. And what I'm picking up there is a little bit of residual magnetism from the motor. Take a look at the pinch roller. Doesn't look bad. It looks like it's got a residue on it. It's actually, I can still feel friction on it. It looks to be a pretty good pinch roller. I'm set up to precision grind this. I'll take it down, give it a good scrubbing. Dawn soap, warm water, and a stiff brush. And as it turned out, that completely brought this roller back. I did not need to precision grind it, even though I was set up and prepared to do it. So again, this deck was almost certainly maintained, and this was probably changed at some point not long ago and then not used. So I prefer the factory rollers to any replacement by far. Just a much better rubber compound than what we can even produce today. And so I'm sticking with this one. And just the tiniest amount of lubricant. Just get it started right there, and then I'll use a little extension anvil. Not quite long enough. Let's go find the other one. There it is. Just right. I'll remove the power supply control board. And I'll do a full recap on that. One thing I see right off the bat here is there is almost no thermal paste left on these regulators. And so I'll take those off, clean them, and put new thermal paste on. Put a little bit of new solder on, make them easier to remove. Don't have a large enough tip on this to get around those, so we'll just wick them off. Maybe. Let's add some solder. Just removing these heat sinks to make it a little bit easier to do. There, finally. Yeah, there's a little bit hiding in there, but you know, I just have the feeling it's not doing its job. And these do run hot. Yeah, there's a little bit there. Okay, start out with paper towel, move on to a Kim wipe. I like to get the old solder off, especially when I'm, you know, upgrading to leaded solder. I don't have the brand on this thermal paste. It's just some I borrowed from a buddy that's an avionics tech. And I'm quite sure it's as good as can be had. So at very least, this will be a better thermal conductor than was on here before. And especially on this one, because when I go to put the screw on, the screw won't tighten down. And this screw was loose to begin with, but I didn't realize it was actually stripped. So this had never been tight. This was probably over tightened at the factory and has never really done its job. So I'll get these cleaned up, and then I'll go make a nut that will go on the back of this. This is not a machine screw. This is like a sheet metal PK type screw. So I can't just grab a nut to put it back there. I have to turn something, and also I need it to be aluminum because I don't want it to have a dissimilar metal onto that aluminum heatsink. Or aluminium, whichever. See that? It doesn't tighten up. And when I loosened that up in the first place, I noticed that it wasn't tight, but I didn't know it was stripped. Okay. Anyway, there's the little aluminum nut I made for it. So with those two upgrades, this will run considerably cooler than it was and had been in the past. Get all that old lead-free solder off, clean the pads. Hold that down tight while I keep the solder flowing. These boards, for some reason, have a very strange coating on the backs, and it doesn't really dissolve with IPA. It takes 2 or 3 cleanings, and then it still kind of turns white. I haven't really seen anything like that before. So there it is, fully serviced and recapped. Now put it back into place. And then I realized I forgot to clean that grounding lug. I like to get the oxidation off those and polish them up and put a little dielectric grease on them. Using non-ferrous steel wool. This is a synthetic product. And IPA. And I just like the deoxit dielectric grease. Okay, let's do it again. Didn't want to bore you with the recap. I've already done that in a previous video on this exact board. In fact, on both of these boards. I like the Deoxit blue S100, I think it is. Contact enhancer, but it's also kind of a lubricant on all the connectors. You can see just how much more easily they glide into place than how they were removed. It's a very good product. Okay, so the transport is fully rebuilt. The power supply is fully recapped and serviced. And I just want to give a quick try out here before I move on to the audio board, or the main board they call it. And that's also shown in the other video. So that checks out. Move on to recapping the main board. So as always, I match and crimp the capacitors in the audio section. And I won't bore you with that. This board has no fewer than 5 of the infamous 4066 noisemakers. Those quad switches, so all those will get upgraded. They'll get put into gold-plated sockets, of course. And I'll just fast forward through all of this. Again, I think on one of the other videos I did show the whole procedure, but I fast forwarded through it, of course, because it takes quite a bit of time. I know this one's already getting long. I've tried to compress something like 6 hours of film down into this hopefully 1 hour video, but I think I'm already past that. Okay, here's these quad switches. And this goes on for a while. This is actually a huge improvement on this board. These were, I guess, what they had at the time, as good as they had, but they are noisy and they need upgrading. I'm going to clean every bit of that old solder up. And this goes on for a while. And another while. I'll scrape off the old capacitor glue. And then while I'm here, I'll remove these two regulators also and reseat those and put new thermal paste on them. I don't need to remove these heat sinks. I have plenty good access to this side. These are also loose. It's not surprising. These are two sheet metal screws on a thin piece of aluminum on the heat sink there, so it's not surprising that from heat cycling they would loosen up. Okay, cinch them down and move on. Okay, I just want to quickly show how I install these sockets, or chips for that matter. Just kind of tape them in place, and I know they're not fully seated. This is how I seat them. I just tack the two opposite legs. Then I reach underneath, I find the socket, and just put a little bit of upward pressure on it. Touch it, and that seats it in place. So now those are firmly down on the board, and there's no chance that they will lift a trace or a pad when I seat the sockets in them, or seat the chips in them. Okay, so that goes on again for some time. And then the last thing that gets done in this particular video is just double checking. Now, of course, I did this before I put it together, but now since I've aligned the azimuth on these, I want to go back and double check and make sure that make sure I'm still good on my head height. Okay, so let me refocus the camera. Okay, so there it is on that guide. And obviously I'm just showing this for the camera. I've done all this with backlighting and this normal way I do it. I'm just kind of showing this so you can see it. Yeah, squared up, right height. Time to make some tests. So be sure to check out the cards and the other links in the description for the detailed videos of the other sections of this rebuild. And as always, I thank you for watching.